A conical tank is 10 feet across the top and 12 feet down. If water is flowing into the tank at a rate of 10 cubic feet per minute, find the rate of change of the depth of the water when the water is 8 feet deep. So let's go ahead and first draw a picture of the situation. We have a conical tank with its vertex pointing down. We are told that the tank is 10 feet across the top. So the diameter of the circular top here is 10 feet. And we're also told that the height, or the depth, the tank is 12 feet deep, so that would mean that the height of this cone here would be 12 feet. So feet from here to here. We also have water flowing into the tank. Oops, sorry, my busted up valve there. But you have water going into the tank. And it is filling up the tank with water. As it does that, the water level creates, sorry about that. As it does that, the water creates a cone inside the tank. It's just this smaller cone here. And that is what the rate that's given is for. So it talks about the water flowing into the tank at a rate of 10 cubic feet per minute. So if the water is going into the tank at that rate, then the volume of this cone here is changing by that amount. So in terms of given information, so the given information is that the rate of change of the volume of the cone with respect to time is 10 cubic feet per minute. What we are asked to find is the rate of change of the depth of the water. So let's say if we call the depth of the water here, we call that H, then what we want to know is we want to know what is the rate of change of the height. So dH/dt. And we want to know that when H equals 8 feet. Alright. So first, they're talking about the volume, they're talking about the height, so what we're going to do is we're going to write down our formula for the volume of the cone. So the volume of the cone is V equals 1/3 pi r squared h. Now, notice that in this problem they give us, we know something about the rate at which the volume is changing, dV dt. So imagine if we were to differentiate implicitly right away with respect to time, we would get dV dt here. Right here we would have to apply the product rule, but eventually when we differentiate this term, we're going to get 2r dr dt. We don't know anything about dr dt, so that would be kind of like an extra step in the problem if we were to actually go that way. And of course we're going to get the dH dt that we want to know about. So we want h here in this equation. So a lot of times when it seems like you have too many variables, what you try to do is find a relationship between the extra variable, in this case r, with one of the other given variables. And so what we want to do is we want to substitute out r. So we're going to substitute out r. So how do we do that? Well, in this case, we go back to our drawing and we complete this picture here. So this r that's in this equation corresponds to the radius of the smaller cone here. Right, so that's r. But notice that if I were to complete this, if I were to, from the center of the upper base, and I go through the center here, like this, and I keep following that all the way down, that I create, and I look at a cross section, that we actually get a cross section that's that corresponds to a right triangle. Within that right triangle, we also have this right triangle here. And these two right triangles are, so this one here, formed by the radius. These two right triangles are similar triangles. They have the same angle measures, right? So you have this angle is the same as that angle, they actually share this common angle, and then, of course, this angle will be the same as this angle. So since they're similar triangles, their sides are proportional. So if I go back to this upper half, this side right here is the radius of that bigger circle, so that's 5. So that allows me now, let me do that in a different color. Let's see here, yes. By similar triangles, I apologize for the writing here. By similar triangles, we can see that r is to 5 as h is to 12. And then since we want to get rid of r, we're going to solve for r here. So r is going to be 5 h over 12. So back over here, so that's what I'm going to do. I'm going to substitute out r with 5h over 12. So I'm going to replace the r here with that. So when I do that, we get v equals 1/3 pi times 5 over 12. Oops. Excuse me one second. Let me fix that. 5h over 12 squared times h. And when we simplify, we get 1/3 pi times 25 h squared over 144. It's 25 h squared over 144 times h. I'm going to go ahead and leave this unsimplified. Well, I'm going to write this like this. It's going to be 25 pi over 3 times 144 h cubed. So now we have an equation that is just relating the volume and the height, which corresponds to the given information and the information that I'm trying to find. Okay, so now I want to take the derivative of both sides with respect to time. So if I take now d dt of both sides, then I will get dv dt is going to be equal to 25 pi over 3 times 144 times 3h squared dh dt. This is why I didn't multiply out the 3 times 144, because I saw that those were going to cancel. And reducing that down, we end up with dv dt is equal to 25 pi over 144 h squared dh dt. Solving for dh dt, I can multiply by the reciprocal of this expression. When I do that, I get 144 over 25 pi h squared times dv dt equals dh dt. And then when h equals 8, feet, we get that dh dt is going to be equal to 144 over 25 pi times 8 squared times dv dt, which was 10 cubic feet. And if we punch that into our calculator, I believe we get approximately 0.29 feet per minute. All right, and that will be it.